family programs, there are four main areas of software development: bridges, structures, geotechnical, and mechanical. Under the bridges, we have MIDAS Civil that can analyze and design all types of bridges from box culverts to suspension bridges, along with the substructure. MIDAS FEA is Advanced Nonlinear and Detailed Analysis System. Under structures, we have MIDAS Gen, which is an integrated system for buildings and general structures, which we will be seeing today. MIDAS D-Shop is an auto drafting and rebar detailing module for RC structures. Then we have over here MIDAS Design Plus, which is a structural component design and detailing tool. Under the geotechnical, we have GTS NX, which is 3D finite element based geotechnical software solution. And there is SoilWorks, which is a 2D finite element as well as analytical geotechnical solution. Under the mechanical, we have MIDAS NFX and MIDAS FX Plus. So we'll be not talking about that, and we'll go ahead now with the structural program, that is MIDAS Gen. MIDAS Gen for buildings and general structures, and we will be seeing some application projects of MIDAS Gen in the coming slides now. MIDAS Gen has numerous applications in buildings like Burj Khalifa that use MIDAS Gen for performing column shortening analysis, which MIDAS is pioneer of. In Torre Eurosco, we see that not only the building but also the substructure, that is piles, can be analyzed in MIDAS Gen. Other applications we see with different geometric shapes for buildings. In plant structures, power plants, steel museums, industrial sheds, silos can be analyzed as well as designed in MIDAS Gen. Some special structures applications include the Beijing Olympic Stadium, badminton arena. Here, this is a complete, fully air-conditioned enclosed steel structure. This is a FIFA World Cup Jeonju Stadium. We see how cables are modeled to know the unknown forces to apply the pre-stress into it likewise. Then in specialty structures, we see here the Masonry Temple and the museum, which has been analyzed using complete solid elements. So MIDAS has applications not only in buildings but power plants, stadiums, airports, hangars, pavilions, subway stations, transmission towers, cranes, pressure vessels, machine structures, underground structures, and so on. We take pride in showing that 5 out of 20 tallest structures in the world have been designed using MIDAS Gen, and this symbolizes the reliability of the software. The upcoming tallest structure is the Kingdom Tower. It has been analyzed and designed by Thornton Tomasetti using MIDAS Gen, even if they have been using CSI product for more than 30 years. The reason is it has really easy interface and makes modeling extremely easy, thus saves time tremendously. Secondly, it has powerful 64-bit solver which enhances the speed excessively and is comparative quickly. So third thing is that it is a specialized software for column shortening, which is very much important for high-rise structures. And lastly, it has a tight integration with MIDAS GTS NX, which is an expert 3D software for pile draft foundation. Kingdom Tower has pile draft foundation, and thus they needed GTS NX as well. Another standing application in UAE is the ADFC building. This is the Kuwait Airport hangar, which has been analyzed using construction stage analysis. So this is the construction stage analysis that was performed in Kuwait Airport Hangar. Another example of Mishrib Station Hangar, analyzed and designed by Tony G. The specialty of this structure is the steel structure supported by concrete core wall. Also, the complex steel joints were checked for local stresses using solid meshing. We shall see this in the demonstration. MIDAS Gen has the capability to import and export BIM tools like Tecla and Revit. After analysis and design in MIDAS Gen, the model can be taken further to MIDAS D-Shop for rebar detailing and bill of materials. The forces from analyzed model in MIDAS Gen can be imported easily by MIDAS Design Plus for bolt connections, base plate design, staircases, and so on. Further, using MIDAS FEA, we can convert our line elements to solid, mesh it, and take it back to MIDAS Gen for solid stress analysis. That takes us further to major strengths of MIDAS structural solutions. The worktree in MIDAS Gen is user-friendly. It can assign properties, saving a huge time. MIDAS Gen also has a text editor that is so user-friendly that a beginner need not have code reading experience. Meshing of planar and solid elements is time-saving and accurate, leaving no node free. Building generation that can copy floors with different floor-to-floor heights is available. Automatic story diaphragms, like rigid diaphragm, is there. Cost effectiveness is achieved by using solid structure interaction. There is automatic wind load, and then further we have this auto excitation angle for response spectrum analysis. Then floor loads and roofs can be, floor loads on roofs can be, or inclined roofs can be applied. Then hydrostatic pressures can be applied onto the structure, and this saves a huge time in applying the loads on MIDAS Gen, in MIDAS Gen. We have high analysis speeds. Under advanced analysis, moving load, heat of hydration, pushover analysis, inelastic analysis can be performed. As a result, program provides automatic story tables and has customized dynamic report generator. When it comes to design, optimization with respect to weight as well as drift is easily performed by the software. Program provides detailed report for clear design calculations with accurate design methodology. Lastly, an independent component design in MIDAS Design Plus can be used. There are a few more strengths I would like to discuss in detail in the further slides. This is regarding Tecla Interface. This is the entire structure in Tecla modeled. MIDAS link can take the point loads and UDLs that has been applied in the Tecla model. So in this way we can filter the objects or the properties to take into MIDAS Gen. Now this is selection of the model to be exported to MIDAS Gen program. this is basically the procedure for taking the Tecla model into MIDAS Gen program. So Tecla is converted into MIDAS Gen text file. We have checked on over here loads as well as the links to be imported. Now this would be saving the file, and after that we will import it in MIDAS program. And here we go, we got the model in MIDAS Gen from Tecla. Next, assigning properties in MIDAS Gen is very easy. All you need to do is select the elements, drag the property and drop it. That's all. And the property has been assigned. When it comes to tapered sections like this one here, we can calculate section properties at the ends. We may also be able to apply offsets and flush the top face. But when it comes to dividing the elements into parts to receive purlins or braces, then in other competitive programs you would require to calculate the section properties at every division. However, this is not required in MIDAS Gen. By using tapered group, program can by itself automatically calculate the intermediate properties. And this would save a huge time. Looking at the types of non-linearity supported in MIDAS Gen, there is elements like tension only, compression only, hooks, cables, as well as gap. Another type of non-linear boundary conditions like tension only and compression only springs, multilinear pile springs, tension only and compression only elastic links, as well as multilinear elastic links. And the good part is the program automatically performs nonlinear analysis when such is defined in static analysis. For local stress analysis, MIDAS Gen can perform solid joint analysis, and we shall see this in the demonstration. Regarding the MIDAS text editor, which is called as MIDAS Gen text command shell, is so user-friendly. As we see here, the commands are easily understood and available under the drop-down, explaining how commands are to be input that you can see over here in the green color. It makes it much more easier to find out or understand how the program has arranged the command lines. The building generation command allows multiple floor-to-floor heights, having different heights, while copying a part of the structure or the entire structure floor plan. Then another advantage is the automatic story diaphragm. The rigid diaphragm can be automatically considered while we are defining the stories. When it comes to floor loads, these can be applied as inclined loading onto the roofs, and we can apply it perpendicularly downwards, like in the gravitational direction, or we can apply it perpendicular to the elements also. Regarding moving load analysis, a huge time is saved over here in this tool. The program, as a result, can provide us the location of the heels due to which an element experiences maximum moments and forces. All the iterations by applying the point loads is eliminated here, thus saving a huge time. Under advanced analysis, steel pushover analysis for performance-based design can be performed in MIDAS Gen. Good part is the hinge properties can be automatically calculated by the program, and as a result, program provides with the hinge status results and performance point from demand and capacity curves. This is regarding the various automatic tables provided in MIDAS Gen. We see here how program can calculate the drifts separately for multi-towered structures. The analysis speed is high in MIDAS Gen because it has 64-bit solver, and it can be further enhanced by using a GPU accelerator. When it comes to report generation, MIDAS Gen has got dynamic report generator, which can update your entire report by just one click. Under the designing strengths in MIDAS Gen, program has capability to automatically calculate the design parameters like effective length factors, equivalent moment correction factors, and bending factors. MIDAS Gen can change the sections in steel code check after the design has passed or maybe failed if you want to make changes further. And before changing, it can provide us, or it will ask us which one to use, which code to be selected, which shape to be selected from. Also, we have user-defined sections from a previously created MIDAS Gen file. After we change the section, the program can reanalyze the entire model with this new section property. In the optimization of sections, MIDAS Gen has advantage to use sections defined by the user. As a result, the program provides various graphs as shown over here. After design, the program provides graphical summary of design result as shown over here. When it comes to design report, the program provides detailed report for every element design as per the code. And as you see here in the highlights, these are the references from the code selected. Quantity estimation, MIDAS Gen can provide us with the bill of materials of the entire steel structure. That was about MIDAS Gen. Now the results from MIDAS Gen can be taken further by linking with MIDAS Design Plus, and further we can design bolted connections, base plates, beam plus column design check, then crane girders, web openings, stairs, as well as purlins and girth. The program provides drawings too. Designed model from MIDAS Gen can be further imported in MIDAS D Shop for auto drafting. That's all in all MIDAS structural solutions. Next, we shall be seeing the demonstration on MIDAS Gen, Design Plus, and also will be using MIDAS FEA for solid modeling. This is MIDAS Gen program. This is the user interface of MIDAS Gen. Over here we have got the ribbon menu all arranged, and the different tabs in the ribbon menu are arranged as per the work procedure. So we start firstly with the modeling, then we apply the boundary conditions, apply the load, analyze the structure, check the analysis results, and further go ahead with the design and get the bill of materials. We can model our structure by using 4 methods, either by using different wizards available. We have truss wizards, plate, shelves, arches, beams, columns, all these. Secondly, we can define line grids and create our nodes and elements. We can import from Tecla files, Revit files, 2D, 3D, DXF files can be imported. SAP as well as STAD files can also be imported in MIDAS Gen. Lastly, we have CAD-based modeling tools, like we can start from scratch creating nodes and elements. In this webinar session, we will be using these CAD type of functions. So we'll be starting with creating the nodes first. In the nodes, we can, while creating the nodes number of times, so I'll copy them at 4 times, that's 6 meters distance, and coordinates is 0, 0, so I'll just click on apply. So here we go, we got all the 5 nodes, and further I can provide with the next coordinate that will be in the y direction, and apply, 18, and apply. So all the nodes are here now. Now further I can create more nodes at the top and then join them for creating the line elements. However, in MIDAS Gen we have got a very good tool, that is extrude function. So in this extrude function we can convert our nodes that we have created into line elements. Further, lines can be converted into planar elements, and planar elements can be converted further to solid elements. This makes modeling very easy. So here I'll be using node to line element. Further, I can just simply select all these nodes and provide an equal distance for now. This would be firstly in the Z direction of 1 meter for pedestals. Then further, I can use these top nodes. I'll be using these two top nodes from the side view for creating the columns, edge columns. So the height for that is 4 meters. And for intermediate columns or middle columns over here, height is 6.15. So now I got the columns and the pedestals, and further we can use now the create elements command for creating our elements. So I can simply join from node to node. Now once these elements are created, I can further copy them onto the rest of the areas or locations. So by using the translate elements command, I can copy these two elements. So we have the equal distance of 6 meters and number of times as 4, and apply. Further, by creating the elements, the rest of the elements can be created by using these node to node function. As you can see over here, I've clicked on the first point and the last point. This will automatically intersect or divide my elements into different parts, as many parts as long as they're getting intersected by elements or nodes. So here we go, we are done with creating this much part. Further, we can have a canopy as well. So we'll have a canopy on the right side. This can be simply done by dividing these all columns using this unequal distance command. At 3 meters from the bottom. And further, all these nodes can be further extruded in the negative y direction. Let's say we have a canopy of 1.2 meters. Minus negative direction. Then further we can also create the tension only elements, inclined tension only elements. So we can just change this element type as tension. We have different options as explained earlier in the presentation, that there is tension only and compression only member types, element types, and hook and cable type is also there. Now this inclined direction, we can use the same extrude function. All we need to do is select all these nodes and use project command over here. We can project it on this line and provide a direction vector. And apply. So very easily we have created our tension only inclined elements at once. Now we'll create the rest of the elements, canopy elements, by using the create elements command. Okay, now let's say we have got crane loading So for that, we need beams on the other side as well. Let's keep it in the center. So by using this translate elements command, can provide even the distance. We can check on intersect node elements so that these columns will automatically get divided. And we can also have these elements right over here. So our entire model has been completed. In case we would like to have more pedestals in between, that also can be done. So all you need to do is select all these elements and use this divide command. Make it equal distance. Let's say you want to divide every element into 2 parts. And say these elements into further 3 parts. And then we can use all these nodes and extrude them for creating our concrete pedestals. So this is done and we are completely done with our modeling part. Now providing certain definitions to our model, we go back over here in the structures tab, like the structure type. We are going to perform seismic analysis onto the structure. Okay, I've got a pop-up over here for saving as, because the program has the capability to automatically save the structure. Alright, so we can convert sulfate into masses, can be converted into XYZ or XY depending on how we are applying our lateral loadings. Then further, we'll go to the control data over here for defining the stories. There is auto-generate story data command. As you can see over here, the accidental eccentricity for wind as well as seismic it can be provided over here. This information is by default as 5% of plan dimension, 15% of plan dimension for seismic and wind eccentricity respectively. So further over here, we can provide the program to select certain levels. So we have got 1, 2, 3 and 4 levels. These are the ones which we'll be choosing. Regarding the rigid diaphragm, which was automatically considered by the program, it's shown right over here. This is consider meaning rigid diaphragm is considered, and we can further change it to do not consider if you want to consider a semi-rigid diaphragm or no rigid diaphragm at all. We can even copy and paste this over here. So this is all Excel compatible. Story names can also be modified. For example, this is our ground level, first floor level and second floor level and roof, so on. Under the wind tab over here, we can see the floor widths, the floor centers and the eccentricities. Under the seismic as well, we can see the accidental eccentricities calculated by the program. If you want to apply the torsion amplification factors, that can be modified from here. So we're done with the story definition and the structure type has been also checked. Further, we have the option over here to check duplicated elements. The good part is the program not only shows us with which elements were duplicated, but also deletes them automatically. So a lot of time is saved over here in finding and deleting the duplicated elements. So this is done. Now we will go ahead to Properties tab. In the Properties tab, firstly, we can create the material properties. Here we'll have two material properties, one for steel and one for concrete, for the concrete beams and concrete pedestals. So the type of design is steel, and we can select from here. These are a number of standards that are available in MIDAS Gen. So I can select over here the American standard and from the database A36 as the material property. We can see over here that the program has automatically provided us with the modulus of elasticity, Poisson's ratio, thermal coefficient, weight density, and so on. And all this information, all these parameters can be modified by us as well. All you need to do is change this to none. So we are going to have one steel property definition and one concrete. The type of design will be concrete. The standard ASTM-RC, again from the database. I'll be selecting grade C4000. These are the parameters for the concrete, grade of concrete. So material properties are defined, and now we can move on to the section properties. In MIDAS Gen, we can select the shapes and select the standard, and from the standard select the section name or the section type. We can also have user-defined section properties from the reference image that has been provided. We can also use the value-based type of section property definition. There is steel reinforced concrete type of section properties available. Combined properties are also available. These are commonly used section properties for steel structures. Under the tapered, we'll be having tapered sections over here as well. So under the tapered over here, we can also have general section or irregular section of tapering. And the good part in the program is that the program can design taper sections as well. And we also have composite type of section properties, wherein you can have, let's say, steel deck, steel girder, and concrete deck. In this webinar, I will be using this import function that is available in MIDAS Gen. So if there are n number of properties that you have already defined in a previously created file, then you can simply use this import function, and from this import function you can also select which of the section properties you want to use or not use. Also we can provide them with new IDs and so on. So I'll be using all these properties over here, and after that I'll just close this. Next part is assigning the properties to our structure. Now we are going to have tapering sections over here. However, for making a tapered section, we can also further divide these elements into number of parts. So I'll just divide these into 3 parts each. We'll have tapering at the edges and a straight element over here at the intermediate locations. Okay, so now we can go ahead and assign the properties. In MIDAS Gen, we have got 2 tree menus. They are identical ones, and we have this workstream menu, which is the main focus. The workstream menu basically lets us know all the information that has been incorporated in the model. So at one glance, you will be knowing if anything has been missed out or if all the things have been carried out in your model. Starting with the material properties now. So as you can see over here, the steel and the column, that is the first ID in the material and the section, these are in black color. This means that these two properties have been assigned to this entire structure, and the ones in the blue are not assigned to any element yet. So we will be assigning the concrete material property to our concrete beams and pedestals. So I can just simply select them and drag and drop. We can just simply double click on the section properties and material properties to see if we have assigned the property correctly to the correct elements. So similarly, I'll be assigning the rest of the properties. Like these are the steel beams, so I'll select these steel beams, drag and drop beam property, tension only, these are tension only elements, so I'll drag and drop tension only property, canopy, so these are the elements I'm going to be using for canopy as well as the other beams that are going to take our crane loading. Now tapered edges, so these are our tapered edges, so I'll just select them and drag and drop. So now as you can see over here, these tapered edges, these are supposed to taper from the starting location to this lower location right over here. So for doing that, all we need to do is simply select them and reverse their local element axis. So in the change parameters, we can simply go to the reverse element local and apply. Next, I'll provide the intermediate Raft property, that is non-tapered center. Then the pedestal properties, and lastly the beams. So here we go, we are done with applying all the material and the section properties to our entire structure. We can also view them by different colors. There is display option, wherein we can randomly ask the program to color our entire structure as per the different section properties that has been assigned. So after this is done, we are done with the properties, and also I'd like to explain about some advantages in the properties that are there in MIDAS Gen. That is the time dependent properties. So when it comes to construction stage analysis and you would like to perform the nonlinear analysis and understand the creep and shrinkage, as well as provide the information of creep and shrinkage property change as per the time, as well as the compressive strength property can be changed as per the time and can be applied to the structure. The good part is that there is user-defined time-dependent material function. After the properties, now we will be going to the boundary conditions to apply the supports onto the structure. So we'll go firstly with defining the supports. Here we can constrain the directions, the translations, as well as the rotations. So for doing that, we have to just check on these boxes. To check on all these boxes at once, we can simply click on D all. This will constrain the translations in all the directions. So for pin type of connections, I have constrained all the translations, and all I have to do is simply go to the front view and select all these lower nodes, bottom nodes, and click on apply. So in this way I have been able to apply the support conditions to the structure. Next, the advantages also I would like to talk about is the surface spring supports for raft foundations. All you need to do is provide the modulus of subgrade reaction, and distributed spring supports can be applied to either the frames or the planar elements. Under the pile spring supports, the program can automatically calculate the multilinear horizontal spring stiffness as well as the linear vertical spring properties. All we need to do is provide the geotechnical data over here. Other than that, there are elastic links, rigid links, beam and releases, beam and offsets, plate and releases, and so on in MIDAS Gen. After that, we can go ahead now to the loading. In MIDAS Gen, we have various types of loadings that can be applied onto the structure. Under the static loads, we have the self-weights, the lateral loads, pressure loads, flow loads. Under the dynamic loads, we have got response spectrum, time history functions. Then temperature loads can be applied. Pre-tensioning can be also applied, post-tensioning, pre-tensioning. Construction stage analysis can be performed. So in case of any boundary change when it comes to steel structures or erection of steel structures, then construction stage analysis becomes necessary. So that can be performed over here. Moving load analysis can be performed. We'll be seeing this as well today. Heat of hydration analysis for mass concreting of structures can be performed, and the good part is that the program has pipe cooling system to cater to the high heat that is generated. Settlement loads can be applied as well as imperfection loads can also be applied. So that is about all the different types of loads that can be applied onto our structure. Now in this session we'll be applying the static loads, dynamic loads, as well as the moving load. So I'll start with the static load cases. Firstly, I'll create one self-weight load case, one for superimposed dead load, one for live load, and due to shortage of time, I'll be having just wind load in one direction, earthquake as well, just to show how we can apply these loadings, lateral loadings onto the structure. So after we have defined the load cases, then we can go ahead now. We'll just follow the left to right procedure. So we'll start with the self-weight and apply with the self-weight with -1 as a scale factor in the Z direction. Then further, because we're going to be performing seismic analysis, so we'll convert our loads into masses. So this can be automatically done as well. So all we need to do is provide the scale factors, self-weight, SIDL, superimposed dead load, and live load as 0.25. So a huge time is saved over here when these loads are automatically converted into masses. Next, we will be applying wind loads. So these are automatic code-based wind loads. We need not perform a lot of calculations. All we need to do is provide the parameters. For example, here we can select ASCE 705. We can choose the analytical procedure, provide the basic wind speed, so let's say 100 miles per hour. Exposure category as C, mean roof height has been automatically taken by the program. Importance factor I'll keep as 1, directional factors as 0.85. Now we can consider the gust effect factor by rigid structure or by flexible structure. Accordingly, the program will change the formula, and we have over here automatic gust effect factor calculation. So if this is a flexible structure, so all we need to do is provide the information like the natural frequency in the x, y direction and the damping ratio. So as I've already found out by performing eigenvalue analysis, the frequency of the structure. So this is x direction, so this is 2.25, and this one is 1.4734, and the damping ratio is 0.2. And by just clicking on calculate, the gust factor effect has been automatically calculated. Gust effect factor. Further, you can choose to apply the wind eccentricities, positive, negative wind eccentricities, and accordingly number of load cases would be added. However, in MIDAS Gen, we have got MIDAS Gen text file, so MIDAS Gen command shell, so we can directly create all the load cases on all these wind eccentricities, or all these parameters can be created at once by using this command shell. Now, for applying the wind loads in a particular direction, all we need to do is provide the scale factor to it. Now, as the major direction is, or maximum force is going to be applied in the y direction, so I will be applying this wind load in the y direction. So the scale factor in x will be 0 and y direction will be 1. Now, before performing the analysis itself, we can go ahead to the wind load profile and see the story forces, story shears, and overturning moments. We can also click on this make wind load calculation sheet right over here. And as you can see over here, these are the formulae used for the calculation of the wind loads. These are the parameters that we have provided to the software for the calculating all these forces and moments. In case you have any additional wind loads that can be applied right over here. If you have wind tunnel test loads with you, then this is additional wind loads right over here, which is Excel compatible. You can simply copy paste from your Excel sheets the loads in the X, Y, and the moments in the Z. And while doing that, all you need to do is simply change the scale factors to 0 for both the directions. So we have applied the wind loads onto the structure. We can even display it by just simply right-clicking in the workstream menu and saying display. So the wind loads have been applied. Next is the seismic loads. Add. And we can choose over here the seismic load code. Let's say UBC 97. We can select the soil profile, let's say SD, and seismic zone factor as 2B, importance factor as 1. And we can provide over here the period from the eigenvalue analysis, or we can provide over here from the code, that is we do have a period calculator that includes all the formulae given in the codes itself. So for the steel structures, the first formula is there, which we can just simply click on OK, and the program will automatically calculate the code, the period. And as I had already performed the eigenvalue analysis, the period for the structure is 0.6787. Sorry, this is in the X direction, this is Y direction. So basically we are going to be performing these seismic loads in the Y direction. So I'm going to be providing the periods for the Y direction itself. And the ductility coefficient, we can say 4.5. And the scale factor as 0 in the X direction and 1 in the Y direction. Further, we can choose the accidental eccentricity to be positive, negative, or none. We can check on these options for considering the torsional amplification factors. Similar to wind loads, any additional seismic loads can also be provided right over here. We can also see the story base shear even before the analysis by clicking over here. Wind load calculation sheet can also be provided by the program. So our seismic loads have been applied because there was no rigid diaphragm. It has been applied onto every node of the floor. So wind loads and seismic loads are done. Further, we can apply over here now. I'd like to show the major advantage in the assign flow loads command. So firstly, we can define a flow load type. The flow load type, basically here we are able to provide all the loading. So it would be roof loading, all the loadings, that is the sulfate, let's say minus 1.5, ideal is minus 0.5, and live load is minus 0.5, and so on. So this is how we can apply number of loadings or load types over here. This means that we need not apply the roof loading for live load separately, dead load separately, sulfate separately, and so on. Now I'll go ahead and assign the flow load. The load type is right over here. We can have distribution as one-way, two-way, polygonal centroid, polygonal length, anyhow. Over here I'll have one-way type of distribution. Now further over here, as you can see that we have not modeled the purlins. So these unmodeled purlins can be included in the flow loads command, and accordingly the flow load distribution will take place. So let's say the number of subbeams is, let's say 5 number of subbeams, and the unit sulfate can be provided over here as, let's say 1.5. And further we can choose over here the load direction if you want it downwards, that is global Z, or we can apply it perpendicular to the local Z direction of the element, that is perpendicular to the element. And further, by just providing over here the loading area instead of any other parameters, just click on to the nodes making the area. So this makes the loading very easy, and as you can see over here, we have been successful in applying the inclined roof flow load. Similarly, I'll do it on the other side. These are the sub-beams. The same thing I'll be doing over here using the same loading, except for the sub-beams, which will be 0 on the canopy. In this way, we are done applying the static loads onto the structure. Next, I'll go ahead now to the dynamic loads. And here, by using these two simple functions, these two simple tools, I'll define the response spectrum analysis loading. And here is the response spectrum function first. We can click on design spectrum and select the code. So UBC 97 with the same parameters that I had chosen for static loading. All these values that you can see, the period and the spectral data, this can also be manually defined. We can copy paste it from Excel sheets. The gravity scale factor has been already included right over here. After defining the function, the response spectrum load case will be defined. Over here, I'll define just the major one. Major as in over here, the advantage in MIDAS is that the program can automatically search the excitation angle at which maximum base shear can be obtained. So let us see what is the angle. The scale factor over here, we can provide the I by R value, that is 1 by 4.5. And then we can check on to use this function and click on add. Then further, we can go ahead with eigenvalue analysis control. We have two types, eigenvectors and Ritz vectors. So eigenvectors is accurate results or accurate analysis result, and Ritz vectors provides us with the 90% of mass participation at lower number of modes, but it excludes some of the masses and only takes in the major masses into consideration. So here we have subspace iteration and line source iteration under eigenvectors. Line source is for lower number of modes, let's say like 30 to 30 number of modes, and we have this subspace iteration for 100 to 100 number of modes. And if more number of modes are required for 90% of mass participation, then it's better to go for the Ritz vectors. Another eigenvectors, here the number of frequencies, this is nothing but number of modes. So this can be, for the structure, it's 80 number of modes for getting the mass participation, 90% mass participation. Number of iterations, I'll keep it 20, and subspace dimensions, I'll keep it as 200. Has to be basically equal to or more than the number of frequencies that we have provided right over here. So we are done with the eigenvalue analysis control. Next, I would like to go ahead now for the moving load analysis onto the structure. So to apply the moving loads, we can simply first select over here the standard. So Ashto LRFT is what I've selected. And it's just a three-step procedure right over here as well. Firstly, defining the traffic lane. So here I can specify lane 1 with 0 eccentricity and 0 wheel spacing, and provide over here by 2 points the line lane. So this is the first lane 1, and I'll have another lane over here. This will be lane 2. So on these two lanes, the crane girder will be moving. Now we will go ahead, define the vehicular loading. So I'll say user defined, and we can provide the loading over here. This is truck loading. However, we just need to provide the information regarding the loads to be applied. So there is P1, P2, P3, and so on. So simply we can have 10 tons on each side, and there will be like 5 tons of P1 and P2 spaced 1 meter apart. provide a name over here. After the vehicle has been defined, then comes the moving load case. I'll just name it as MV, and we can click on add over here and select minimum number of loaded lanes, make it 1 and maximum as 2. And I can provide the number of lanes on which this loading needs to be applied. And click on OK. So we are done with the moving load analysis, moving load cases as well. And now we can just simply go ahead to the analysis tab, and over here we can click on this moving load analysis control, and I'll check all these parameters right over here, how the analysis method has to be, point selection, inference, generating points, number of line elements, and so on. And after that we can just go ahead and perform the analysis. Here, as we had applied tension on the elements, iterations have been taken place for nonlinear analysis. We can also perform p-delta analysis, buckling analysis onto the structure under the buckling. Buckling analysis can be applied. Then further we can perform non-linear analysis, wherein we can include the geometric non-linearity or the material non-linearity. So basically the geometric nonlinearity is for the large displacements, large displacement analysis. So that is what is available in MIDAS Gen program. So within 2.67 seconds itself, our model has been analyzed successfully, and now we can go ahead to check the results. Now firstly, we can see the excitation angle of the response spectrum analysis. So over here, you can directly double click over here and check the excitation angle. So the excitation angle over here, as you can see, is 0. It has been applied in the x direction. We can also go ahead and check the mode shape of the structure. So here we can see the table for finding the period and the frequency. And here we can see the mass participation, modal mass participation of the structure. So you just need to take care that we have reached more than 90% of mass participation. So we have in the X, Y as well as rotational, RZ. And then we can go ahead and find the scale factor to increase, or a scale factor to scale up our response spectrum base shear as per the static base shear. So for that we can find out what is the static seismic base shear. 293. And we can find out what is the response spectrum base shear. That is 203. And we can use Excel sheet, simply copy information, as you saw, this is 293.29, and then the scale up factor would be static upon dynamic. So 1.44 is our scale factor. Now this scale factor, we can choose to apply it for the response spectrum load case, or we can directly apply it over here in the load combinations while we are generating the load combinations itself. So we can click on this auto generation. This is just for general load combinations to be created. So let's say for steel, we are using ASC LRFT 10. We are going to add the envelope over here, and from here we can provide the scale-up factor. So here we go, serviceability as well as strength load combinations has been created, and accordingly the envelopes have been automatically generated by the program. By looking at this description, we can easily identify the load combinations, and these are the scale factors which we can modify. Now for performing the design, we need to also create load combinations under the steel and the concrete tab. So I'll do that for steel as well as for the concrete for our pedestal and concrete beam design. So ACI 31814 is also available. Now the good part is that over here we can select which of these load combinations are to be used or not used in our design. Next, let us check the results now, like the reactions. We can select over here the load combination. Let's say maximum strength envelope. We can see the values on the screen and the vertical reaction. As you can see over here, this red arrow, this is where maximum reaction has been obtained. We can also get this reaction table. We can simply select the load combination. We can also select number of nodes for which you want to see this reaction table of. So here we go, we have got this reaction table which we can further sort as well as per the component. So we can identify that this is where maximum vertical reaction has been obtained at node number 9, and this is 319.25, which is maximum reaction. This entire table can be taken into Excel sheet. All you need to do is click over here to select the entire table, right click, copy and paste it into the Excel sheet. You can also just right click and export to Excel so that a new Excel sheet will be automatically generated by the program. This is about the reactions. We can now check for the displacement contour as per the serviceability condition. Deform the shape, check the legend, animate, animation is also there, and values. We can display only the maximum value onto the structure. So this is 32 mm is the maximum value or maximum displacement that is going to be occurring at this location at these nodes. Now to do the animation, you can just simply press record, and further this animation can be also saved in the form of AVI file format. This was about the displacement contour. Now forces. As we have tension on the elements, we can check the forces in the tension on the elements from here. So only these are the maximum values only. I'll uncheck this, right? So we can see over here the forces. In the tension on the elements. Now let us see the beam diagrams. So we can see the beam diagrams, let's say for load combination number 1, My is flexural moment about major axis. You can check on all and a solid fill to the diagram. So here we go, we have got the beam diagrams, and if you would like to check the beam diagrams for only one particular frame, so you can just simply select that frame and activate it to only display that one frame. For every result, we have the tables. By just clicking on this three dotted box, we can access them easily. So this was the results about MIDAS Gen. Now this last one, that is the story tables. So MIDAS offers story tables. There is story drift right over here. Can select the response spectrum load case. Provide over here the importance factor as 1, scale factor for dynamic as 0.7 into 4.5, that is 0.7 into R for scaling the dynamic drift, and the allowable ratio, since the scale factor was less than 0.7, the period was less than 0.7, so we are going to have this allowable ratio as 0.002, and we can use this response modification coefficient as well. So this is the drift in the X and this is the drift in the Y. So here we go. The drift at the center of mass and maximum drift of all vertical elements has been displayed. So here we can also check that the program has automatically said OK or not good according to the allowable story drift ratio. And we can also create graphs out of this. For example, for maximum drift of all vertical elements and allowable story drift ratio and the story. So right click and say show graph and click on OK. So here we can see this is the drift, story drift ratio, and this is the allowable one. There's a huge gap, so we can further reduce the size of the members. And similarly, we have got different story tables available right over here. Fabric coefficient check can be done, torsional irregularity can be checked, and so on. Alright, so this was about the story tables. Now after this checking the results, we can go ahead to perform the design. Now in the results, again, one more thing is remaining, that is the moving tracer for the moving load analysis that we had performed. So we can check the beam forces and moments now. I'll activate the entire structure. So let's say I want to check the forces and moments for this element. So this is the key element number 1, number 88, okay? And I want to see the moment at the half of its at the middle location, and click on apply. So this is the location of the wheels. So the crane wheels closer to this particular girder will give the maximum moment for this particular element. And the maximum value can be seen right over here. It is 77.08. So similarly, we can further go on checking for every element what should be the maximum value and where is the vehicle loading applied. The program can also provide with the influence line diagrams. So this is done with the results. Now we can go ahead with the design part. Under the design, the program has the capability to automatically calculate the effective length factors depending on how the definition of frame is braced or unbraced. There is member assignment tool as well. So herein we can see that there are certain members, like these columns are divided into two parts. So we can make the program design them as one. So all these columns have been selected. And we have clicked on apply. And then further we can go ahead and perform the steel code check by using the AISC LRFD. We can change the code as well at any point in time. So I'll just click on steel code check over here, and the program will perform the steel code check. And as you can see over here, the program has provided if the member has passed or failed, and we can see for if, okay, so this member has not passed, it's not good, so it's not passed. So we can check in the graphics, and we can see over here the reason for why it is failing. So as you can see over here, the deflection checking results, it is failing in deflection in the y direction. So that brings us to the serviceability parameters. So the serviceability parameters by default for beams is L by 360, for columns is H by 300. This can be further modified as per the requirement. For example, it's 240. We can apply it to all the structure. Then further we can also ask the member to be modified as either the beam or column member or the brace type of member. For example, these are inclined elements. The program automatically designs the inclined elements as braces, and horizontal elements as beams, and vertical elements as columns. So all you need to do is simply select the elements which you want to design as either beam or column. So for this case, I would like to design it as beam, and click on apply. So these are the beams. This is going to be the bracing itself, and the rest are as per the default. And then I can go ahead further and perform the steel code check again. Okay, and as you can still see that this beam is failing. It's 0.228. We can go ahead and perform this change over here so that the program can select from any standard, select from any shape with the limit combined ratios, that is demand capacity ratios, we can check. So these are the different section properties that the program has provided us with. And we can simply select them, and we can say change and close. And then we can click on update and reanalyze the structure and recheck the entire design. Okay, so again over here, this section is also not good enough. There is still deformation. In fact, the deflection has increased. Basically, we need to increase the thickness of the web, and that would be the required thing. In this way, we can go on changing the elements and checking and reanalyzing the entire structure. The good part is the program provides us the results graphically. As we can see over here, a short summary is there, as well as it can provide the detailed report for the entire structure or all the elements, not just one but all the elements. All we need to do is select them and click on detail. So as you can see over here, the program has provided us with the references from where particular table has been utilized, and the checks have been performed. We can also see which of the elements have passed and failed. So all you need to do is say not good over here, connect to the model view, and select all of these. So as you can see, these are the elements which have failed, and you can further do the modifications. The program also has capability to perform steel optimal design. So as you can see over here, the demand capacity ratios for few are very low, which we can modify. For example, for the canopy right over here, you can just check this on. We can ask the program to perform number of repetitions, or if we keep it as 0, then the program just will provide us with the optimized section property without performing iterations. We can also have this user-defined section database from which it can select and provide us a result. And then I can just perform the design and analysis. So this is the section property that it has come up with. 200, it was firstly 200 by 200 into right, and it has modified to 200 into 150 by 5. We can just click on this graph report. These are the several graphs that the program has provided. This is the original weight ratio, and this is after the optimization has taken place. So this is how we can see that we can further optimize our entire or our section properties, as we had performed only for canopy. Right now here we can see the change in the maximum ratio for the canopy structure, the section property. So this was about the steel optimal design. And we could also see that the tapered sections were also checked for. After the design has been performed, the program can provide us with the bill of material. The weight, as well as we can see over here the paint area. So this is an advantage over here in MIDAS Gen. Further, we can go ahead and we can analyze or perform solid analysis for our joints. We can take or align elements and convert them into solid elements by using MIDAS FEA program. All you need to do is simply select the elements and take them to MIDAS FEA. So I'll do the same thing. For that, I'll need to change the local direction for dividing the elements. So firstly, I'll remove my member assignment. This one. And then going to the node element, change parameters. So here I can just reverse. Let me firstly display the local direction. So this is the local direction of the elements. Now I would like to use this divide element command and use this unequal distances so that I can divide these elements until 1 meter of distance. That is the reason why I'm changing the local direction of this element. and then further divide them at 1 meter. Select these elements and apply. So we have now all these divided elements. Now I'll take these line elements and export them to frame section for solid. So these frame elements can be further taken into MIDAS FEA. This is MIDAS FEA program. Just make a new file. All we need to do is simply say frame to solid element. This was a frame element. As you can see, those have been converted into solid elements right over here. And further, we can go ahead and mesh these solid elements, but before that we can, for nodal connectivity, we can perform certain operations like Boolean cut. Cut operation. Then further explode our compound elements to shell. And then further we can divide them. Sorry, we can just simply delete the paths. So some extra portions have been deleted. Now we can convert these shell elements into solid. So now we have got 4 solids. Next, by using Boolean cut, we are going to make sure that the nodal connectivity is maintained. Actually, just wanted to quickly check with you. Over here, this will be the master, and these will be the Boolean tools. Okay. Okay. Similarly for this. Okay. So this can be hidden, and as you can see over here, these are the markings. This will ensure that there will be nodal connectivity. Okay, so for submission, and now further we can go ahead and mesh this solid element. So there is auto mesh solid. Can select all the solids right over here and provide the element size, let's say 0.02, and we can create properties for this. So we can select the material from the database that is available in MIDAS FE as well. So here we have The ASTM are A36. You can select this.
Do you need the license, and I can remove that?
Provide over here the name of the property.
Okay.
And then click on OK.
No,
So the program
no
is going to perform the
just
meshing. As you can see over here, the meshing is pretty
but,
fast
like,
and
do we need a
pretty
follow-up as
clean
such,
right over
because
here.
as you know, when I go to higher management,
Now further, for putting
always
this
keep
solid elements into MIDAS gen, there are just few things that we need to perform, like we need to change the number of nodes and the number of the elements, node numbers and element numbers, so that there is no replacement of the element numbers that are in MIDAS gen program.
And,
so that entire operation can be performed. You can just simply go to the tables.
Okay.
And we can modify the number. So here we go, we can just simply copy this and paste it in.
Okay, no problem. And I'll be just
over here.
removing your ID so that you can use it again.
And this is 15,691, so you can just start with 16,000. Copy this and paste it right over here. After the node numbers are pasted, we can go ahead and modify the element numbers. So basically, when all this has been performed, we can take the entire model into MIDAS gen program, because we have almost crossed all the time. So I'll just take to MIDAS gen program. Well, this is another model file, this similar model file basically. And as you can see over here, this is how the solid has been imported in MIDAS gen program. These are the line elements and these are the solid elements. We can see right over here in the line model view, unrendered view. Now these solid elements have been connected to these line elements by using rigid links, so that can be performed very easily in the program. And after this, the analysis has been performed again. So for this model, the analysis has been performed. So within 74.26 seconds itself, the entire analysis has been performed for the solid. And then we can simply go ahead and check the results. There is solid stresses. We can select the load combination and we can see the effective stresses of our solid elements. Before the results are shown, I'd like to just take you back over here in the element numbers. When the element numbers are changed, then we go back to MIDAS gen program, and then all we need to do is just select these and delete them, and then all we need to do is import we have to go over here in tools and run the mgt command shell for the mgt file that has been created by MIDAS FEA, and then just simply run it. as there are a lot of almost 16,000 number of nodes, and elements are also huge numbers, like 18,000 numbers. It's taking a little bit of time to import it right over here. Okay, this is a different model file, but basically this is how the solid elements get imported right over here. So as you can see over here, these are the stress results, solid stress results, which we can further check over here, the local stresses. So that was it. We can also check the legend over here for the solid stress results. This is in Newton meter, can change it to Newton mm. At any point of time, the unit system can be changed to check the results. Alright, so 73.94 Newton per mm square is the maximum stress that has been obtained in our connection. So this was about how solid elements can be created and analyzed in MIDAS Gen for local stress analysis of the connections. Now further, when it comes to design of base plate, we can directly go to MIDAS Design Plus. From the tools, directly from here to MIDAS Design Plus. This is MIDAS Design Plus program. In MIDAS Design Plus, we have got the project mode, simple mode, and check mode. So in case of project mode, we can get the drawings and the quantities along with the member list. In the simple mode, we can just get the members and the design results. Check mode is when we cannot put the inputs, but we'll just see the outputs provided by the program. Here we can see these are the different members that can be designed in MIDAS Design Plus, like the beam column, then the base plate design, port connection design, plane girder, purling girths, web openings, and staircases. In this session, I'll be showing how base plate design can take place. Herein we can provide the material information, the forces, the information regarding the base plate, addition of pedestals, if you want to use the rib plates, number of anchor bolts, and so on. We can also link our MIDAS program to open over here. One minute. Just reopen the program. Alright, I'll just open up the model file. And further, I'll just link MIDAS Design Plus with MIDAS Gen. And in the base plates, all we need to do is simply use the design or analysis results from MIDAS Gen. So I've selected this particular node right over here from which the analysis results will be taken, and click on import. So as you can see over here, this is the member that has been taken from the program, and these are the forces that has been taken from the program. We can change the concrete material from here. Then further we can even change the section if in case we would like to change the section and check with some other column section property, and the base plate dimensions can also be modified. The pedestal dimensions can be modified. We can choose to use the rib plates. We can provide over here our own number of anchor bolts, or we can ask the program to find the number of anchor bolts required. Wing plates also can be selected to be used or not. And after this, we can just simply click on design so that the program can by itself provide us with the number of bolts. And this is how we can see over here the calculation results. These are the demand capacity ratios, as we can see over here in the brackets. The bearing stresses for the base plate, rib plates, wing plates, anchor bolts. We can modify the number of rib plates and the anchor bolts and everything, and we can further perform the check. The program provides reports in the form of Word file. So I'll just open that. Basically, we need to also save this file so that the Word file is generated. Okay, so here we go. Our Word file has been generated, and now we can, if we close this, then of course this Word file will not be saved, so we need to save this Word file as well. Yeah, so here we have all the properties of the section and the information regarding the base plate design, the design forces, the bearing stresses. Finite elements can be seen over here, how the meshing has been done and the stresses have been checked for. We can see the anchor bolts in tension. These are the ones in tension. The tension forces, tensile strength of them. This is regarding the base plate, moment, XX, MYY, shear forces in the base plates in the X and Y direction. These are the force diagrams for the rib plates and the wing plates. And lastly with the anchor bolt check and the development length for the anchor bolt. So this detailed design result for the base plate can be provided by MIDAS Design Plus. It can also provide us with the drawings. So I can just simply click on create and the drawings can be generated by the program. This workspace is similar to AutoCAD. All the commands are acceptable. You can also save this drawing in the form of .dwg format. So this was regarding the base plate design in MIDAS Design Plus. Now lastly I would like to show the both connections in MIDAS Design Plus. So here we have the material properties definition, the beams or columns and the connection types that we can choose, either the girder splice, column splice or shear connection, if single shear or double shear. If you want to consider the eccentricities, the shear has been taken actually from the program itself directly. Then the material for the bolt can be modified, type can be changed, and the spacing extension and the gap is can be automatically designed and found out by the program itself. So this is regarding the web, number of bolts per side and the thickness of the web plate. And then we can just simply click on design and check the design results. Similar kind of report will be generated by the program, and also we can see the drawings. So this is the detailed drawing that has been created by the program. These are some other bolted connection drawings that has been created earlier. This is the girder splicing, this is the column splicing. So this was about MIDAS structural programs. We saw MIDAS Gen, MIDAS Design Plus, and for just converting our frame elements into solid elements, we saw MIDAS FEA program. So now I'll be going back to the presentation. Now to get the most out of any software that you use, a proper training is the first and foremost requirement. So what could be better than the training provided from the software support team itself? So we are the ones who know most about the software, right? Users always tell about the training programs they received from us and how helpful it was to their needs. So you can, if you have a software that you cannot, you can do everything, but if you cannot use it, then what is the point, right? So if there is no training, there is no gain. Usually when you need support, you do one of the following. You can call or email your colleagues and go through the manual or tutorials to find the solution. You might not exactly find what you were looking for. This is where software support team comes into play. When you contact software support team for answers, at least one, if not all three questions come to your mind. How long it will take for my queries to be answered? Are the people answering my questions engineers or just software developers? Or are they located locally? At one point or another, you all must have had one, if not all, questions in your mind. When trying to get help on a software, it's frustrating, I know. Let me tell you the answer of MIDAS to these questions. Queries are answered within 24 working hours. Being a technical engineer myself, I assure you that the people answering your questions are all civil engineers with both software and practical knowledge. Now, that brings us to last MIDAS technical offer, that is MODS service, MIDAS on demand services, along with this structural package, which includes the easily accessible materials like tutorials, manuals, frequently asked questions. Then we can conduct training programs at your office. You would be invited to monthly training webinars, seminars and workshops. Now the best technical support can be provided if you can easily contact us. So we are available on the online chatting using messengers, WhatsApp and so on. We have immediate help desk, and we can also arrange for an on-demand meeting for say your ongoing projects. So this is regarding the MIDAS services offered for its users. If you would like to know about the pricing of MIDAS structural solutions, kindly write to shishir@midasit.com. And if you have any technical queries, you may write to me at nivedita@midasit.com. So let's look at some questions. Okay, you can download the program. There's a question